Today we're gonna discuss what is the web of things, right? The earlier advertisement that I've shown to you, he spoke about human things and the way he's speaking to the car, and even the car is speaking to that person. So believe me, we are not far away. Maybe 2 years, 3 years down the line, you never feel alone in your house. You always have a refrigerator to speak with, or maybe a television you can always communicate with, right? And there are so many things that you can speak with, right? And they will interact with you. So I think that is not we are far away, right? So let's try to understand what is the web of things actually, right? So we will be probably trying to cover in a session if possible. So connecting everything to the internet and giving them an IP address is only the first step towards the Internet of Things. Please read it very carefully. Connecting everything to the internet and giving them an IP address is only the first step towards the Internet of Things. Things could then easily exchange data with each other, but not necessarily understand what the data means. This is what the web protocol like HTTP brought to the internet, a universal way to describe images, text, and other media elements so that machines could understand each. The WoT, or you can say Web of Things, is simply the next stage in this evolution. Using and adapting web protocols to connect anything in the physical world and give its presence on the World Wide Web. That is what the next step for IoT. The Web of Things is a refinement of the IoT by integrating smart things not only into the internet but into the web architecture or an application, right? So for example, the way you open the Google, the way you open the, let's say, Microsoft.com website, probably I can open my refrigerator right by its name on my Explorer probably, and I can see whether the milk is available or not, whether the tomato is there or not, or maybe orange is available inside my refrigerator or not, and I can take a decision, right? So that's what we are trying to say by means of Web of Things. Let's try to understand what Wikipedia says. The Web of Things is a vision inspired from the IoT, where everyday device sees an object. That objects that contain an embedded devices or a computer are connected by fully integrating them to the web. Example of smart devices and objects are wireless sensor networks, ambient devices, household appliances, etc. Unlike in the many systems that exist for the IoT, the WoT, that is Web of Things, is about reusing the web standards to connect the quickly expanding ecosystem of embedded devices built into everyday smart objects. Don't worry about this definition. We're gonna explore in a very simple language. Well accepted and understood standards and blueprints such as URI, HTTP, REST, RSS, etc. are used to access the functionality of the smart objects. I'm sure some of you must have heard the rest. If not, please try to explore on the net. Look at this diagram. This diagram can be seen in a vertical form, I mean column form. It has a two division logically, the left hand side and the right hand side. On the left hand side, the people are not happy. On the right hand side, it's very easy, right? The life is very easy. The happiest person that we have on the right hand side. So if you look at on the left hand side, what we have is the Internet of Things. And if you look at those hardware stuff and those connectivity mechanism and those connecting standards are really a tough job for a non-technical person like Kirana store wala, right? He does not understand the Bluetooth, Zigbee, or any other standard that you speak about, right? And if, let's say, some device is not able to get connected by him or her, they get frustrated, right? I hope you understand what I mean by that, right? But when it comes over here, for example, you provide this kind of interface like camera on web, right? For example, you can have a light on a web, you have your heating and cooling system on the web, right? Then it's become so easy for every person, right? So what is the difference that I want to tell you here by this diagram is IoT is something which can be explored and understood and implemented by a technical person But when it comes to the web of things, it's like an internet, right? Everybody can use it. Even the arts or the commerce or a non-computer background fellow can jump into that and he can utilize it, right? So if we want to see the same growth that we have seen for internet and social networking, for IoT, it has to be converted from an IoT to something called the web of things. I hope you understand what I mean by that, right? So let's look at this vision actually. And if you look at this diagram, it has started from 2010. On the x-axis, you can see it's from 2010 to 2025 and above, right? So what we have here is it's a home and personal. Then we went for enterprise, utility, transport, and the most important is this one. If you can look at carefully here, plug and play smart objects. Plug and play smart objects. What I mean by that, if you remembered in the last session or maybe before that, I have given an example. When we used to buy a pen drive, we used to get a small CD which has a driver for that pen drive. But nowadays it's not required. You buy a pen drive and it's plug and play because operating system becomes so smart, right? Uh, for example, let's say you buy a Timex Reflex smart band, Timex smart band. What do you need to do in order to communicate with that smart belt? You need to install an operating system, an application into your mobile phone, and then through that application. But can we have a same mechanism like whatever the device I have, my operating system that's an Android or iOS will support it directly without installing anything? That's what we are talking about, right? So this is the vision, and probably I'm going to share this slide with all of you, so probably you can go through it and you will understand. Let us look at this architecture, right? So without going into the detail of the IoT architecture now, I'm showing you something called the WoT architecture, Web of Things architecture. I am sure most of you know the TCP/IP model, right? It has a 5 layer like physical, data link, network, transport, and application layer. Here you have to look at the Web of Things architecture. If you look at the lowest part, this one, what is this? Networked things, right? Network things. What you have there, you can see you have a QR code, you have an NFC, beacons, Bluetooth, Zigbee, Thread, Ethernet, 3G, 4G, 5G, Wi-Fi, right? And the things, and the board like Arduino board, right? So all these network things, that means your things is connected to the internet. So that is what the lowest layer of the WoT. Please understand, IoT is the lowest layer of the WoT. This is what you mean by network things. You have a thing, it has been given an IP address, and that becomes this layer part, layer entity. Above that, you have a layer 1, which is called an access layer. Layer 1 is called an access layer. You have a layer 2, which is called a find. Layer 3 is a share. Layer 4 is a compose. Right? If you look at the layer 1 access, you have different technologies available here, which has been specified here. Probably some of the technologies we will touch upon in the future, right? But what you know right now is the HTML, all of you know, right? I don't know how many of you know JSON also, but I'm sure some of you must have been introduced to the JSON also. Some of you have an idea about the URL and URI also, right? So, and these are the protocols, MQTT, COAP, we gonna study in very detail. If you don't have any idea about the REST API, I advise all of you to do Google search and try to look at what is the REST API, right? I'm sure most of you know the meaning of the API, right? The layer 2 is the find layer. I will go in the detail also of each layer, few example and few real-time things I will show you. Layer 2 is the find layer, where you have a web things model, you have an RDF, you can have a JSON LD, right? For example, you can have a semantic web or MDNS. You must have heard a DNS, right? Domain name system. Here it's an MDNS, a REST crawler, right? That's a part of the layer 2. That's a find layer. The layer 3 is the share. So access, find, and layer 3 is the share, right? In which you have an OUTS, that is O authentic. I think this is some of you must be aware about this. This is a very famous technology nowadays. I will tell you what I mean by that, right? You can have a social network that you know, social WOT, right? Encryption, those things comes in the layer 3, and the layer 4 is the compose, right? So for example, Node-RED, or you can have a web applications, right? Or system integration. So whatever you have, this compose layer is going to be the topmost layer in the web of things architecture, where probably we are allowing user to interact, right? So this is how your web of things architecture looks like. Let me explain you in bit detail, right? So as I said, TC, whether you say TCP/IP model or OSI architecture, I hope my, so just like the OSI led architecture organizes the many protocols and standards of the internet, the WOT architecture is an attempt to structure the galaxy of web protocols and tools into useful framework for connecting any device or object to the web. The WoT architecture stack is not composed of layers in the strict sense, but rather of levels that add extra functionality, as shown in the figure. Each layer helps to integrate things to the web even more intimately, and hence making those devices more accessible for applications and humans, right? So that's what we have shown in the diagram, and I have already shown this video, right? Example of human things. Let's try to look at the first part. What was the first layer of this diagram? Access layer. What is the lowest layer? We've already said the IoT, basically network things, is the lowest layer. Above that, what you have is different access layer. So let me explain you that layer 1, access layer, right? Let's look at this access layer, what it does basically. This layer is responsible for turning anything into a web thing that can be interacted with using HTTP requests, just like any other resource on the web. In other words, a web thing is a REST API that allows to interact with something in the real world, like opening a door or reading a temperature sensor located across the planet. To illustrate this, the sensors of our Pi can be accessed via simple HTTP request on the following URL. For example, let's say I'm copying one URL in the chat window. I wish all of you to explore it. Let's view, right? So I'm opening here also and pasting it in the chat window also, right? I hope you are able to see my screen, right? Yes, you are able to see my browser in Q&A. Oh, great, great. So I will share this PPT, so don't worry. So I open up one website, and you can see my WoT Raspberry Pi board, and it shows me the sensors, right? A list of the sensors available currently on the device. So it's a temperature sensor, humidity sensor, and passive infrared. So I will click here. Let me click there, right? And can you see the value? Hello, boys and girls, can you see the value? Yes, it's a 22, right? Its value is 22, and so it shows the current value, right? Similarly, if I go back and if I click on, right, humidity sensor, you can see the value 35, right? So these are the things like this, right? And you can check what is there. So this is a classical example. What you are able to do, you are able to find the things on the web actually, right? You are able to access the things, you are able to access the things on the web. Let me go back to the presentation. What we are trying to say, this layer is responsible for turning anything into the web thing. Please understand, access layer, it allows you to convert any IoT concept into WoT things. What you are doing here is navigating the RESTful API of a Pi, which has been configured on the Pi, just like you would be browsing a web page. So basically, Pi board has been configured, and what you are navigating is the RESTful API, the way we browse any website. So another thing that I want to tell you is HTML is a great for humans, but not always for machines who prefer the JSON notations. Our Pi provides both, run the see even you can try later on this. I'm not going in that detail right now, but you can pass this command and you will get it. You will see the humidity level in a London office where they have deployed this pi board, right? This is the ideal first step to build your first application that expands the web into the real world. See, this Raspberry Pi board has been deployed in the London, and this is openly available like this. I will give you this. You can pass this command also, and you will get all these details, right? So what we are trying to say is a simple, IoT device like Raspberry Pi board can be demonstrated by having this layer one access layer, and that's how you are demonstrating how a temperature sensor could be browsed on the web, right? So this is the first layer, access layer, where if you can see here, friends, again, let me show you the diagram. You can see the REST API that we can use, right? So this is what you mean by the access layer. So basically, this layer one will have a capability to get converted any IoT thing into the WoT, right? So this is the access layer. The second one is the find layer. So let me take you to that part. Many IoT scenarios are real time. Instead of your application continuously asking for data from Pi, see यहाँ पे एक क्या था कि मैंने जाके उस पे क्लिक किया sensors पे and it shows me the temperature, right? But what you can do is even you can ask your IoT device to continuously push the data to you. So you want it to get notified when something happens in the real world. For example, humidity reaches a certain threshold or noise gets detected during the night. This is where another web protocol can help, WebSocket. Please understand. So this JavaScript code below is enough for a web page to automatically get the temperature updates from WoT Pi. You can paste it in the console of your web browser and you will see the Pi pushing the temperature every second to your browser. Right? Probably I can show you that also, but right now I'm not going into detail. Let me finish the session in the flow and then probably we can play around. So if I paste this code into my browser, the data, rather than every time I have to go to that page and ask for data, it start pushing me the data, right? By just writing a simple WebSocket code, right? So that's how you can use a web protocol like this. uh, Layer 2, which is the find layer, right? Again, let me show you the diagram. Layer 2, find layer. So if I said about access layer, where you have a facility to read the data from a specific sensor, like browsing a web page, and even you can use a web sockets kind of things to push the data automatically, right? Now second layer, let's try to look into that find. So what it does, marking things accessible via an HTTP and WebSocket API is great, but it does not mean applications can really understand what the thing is, what data or services it offers, and so on. This is where the second layer find becomes interesting. This layer ensures that your thing can not only be easily used by the other HTTP clients, but can also be findable. આપણે કહીએ ને ગુજરાતીમાં શોધેબલ કરી દે, right? And you can search findable and automatically usable by other WoT applications. The approach here is to reuse the web semantic standards to describe the things and their services. This enables searching for things through the search engines and other web indexes, as well as the automatic generation of the user interfaces or tools to interact with the things. At this level, technologies such as JSON LD are in use, a language for semantically annotating JSON. This is the JSON LD is a language for semantically annotating the JSON. This is also where standards such as Web Things model help. They define an abstract set of REST resources that things should offer. Right? Let me show you something. I don't know how many of you know. Let me go to the another window. Just allow me. Right? I hope you are able to see my Internet Explorer, and let's say I'm writing here Google. I'm sure you are able to see the Google page, and I'm writing here, right? And you can go to this web page probably, right? And see, this is what is this? The search engine for a IoT, basically, right? The way we have a Google here, you can search for things, right? See, this is what is the world first search engine for internet connected devices. So you can search out this, right? You can do a browsing on this search engine, right? And see, probably if you go down, you can see something very interesting. This is what, who buys smart TVs, which countries are building the most wind farms, what companies are affected by heart rate, right? This is you can click here probably, and there is a Chrome plugin also available, Firefox plugin is also available, right? So these are the things. For example, let's say I place here IP camera. Let me write this. IP camera. I don't know what I will get. Let me write, but probably it will ask me to do login. Can you see something it got for me, right? Total results on the IP camera. Now there are some public, there are some private camera which has been installed somewhere. There are some honeypot also. Also be aware. Don't blame on me. Sometimes if you open any other link, probably they will allow you to enter somewhere, but then you should not get captured somewhere, right? So there are a lot of security concerns over it, but these are the things that you can explore. Probably you can click here and you can explore. This is not something that I should show you everything over here, right? Some unexpected results you can expect sometimes, right? Not always, but this is what it allows you, right? You can find the things. You got the point. You can find the things, right? You can find the things. So let me take you again to my presentation part, right? So let me take you again. Yes. Uh, Look at this. What you have? The first one was the layer one, that was the access layer, right? And in the layer two, what I have shown you is the search engines. Hello, right? In the layer two, you can find the things. So I have shown you the search engine in form of Shodan, right? That you can always use. There is another search engine also. I leave it to you guys to work around. So I have shown you the layer one access, layer two find, and the layer three is the share layer, right? Let me take you to that part now. So layer three is the share layer, right? I hope all of you understand what we mean by the share. The IoT will only blossom if things have a way to securely share data across services. This is the responsibility of the share layer, which specifies how the data generated by the things can be shared in an efficient and secure manner over the web. Right? For example, let's say you have a temperature sensor and it's successfully deployed and it's reading the temperature all the time from a specific place. But let's say you are not sharing that temperature value. You are not sharing that temperature value. Do you feel it has some meaning? No, it has no meaning, right? Because if you don't share it, it has no value, right? If you share, probably someone can take a decision based on that. So at this level, another batch of web protocol help. First, TLS, the protocol that makes the transaction on the web secure. Then techniques such as the delegated web authentication mechanism like OAuth, which can be integrated to our things API. Finally, we can use the social networks to share the things and their resources to create a social web of things. I request all of you to spend 1 or 2 minutes to do a Google search on this OAuth. Or let me show you that. You can see my browser right now again. What is this? OAuth 2.0. Oh, what is that? Is the industry standard protocol for authorization. It focuses on client developer simplicity while providing specific authorization flows for the web applications, desktop applications, mobile phones, and living room devices. Very important. I wish all of you to read it again. This specification and its extensions are being developed within the IETF Authentication Working Group. All of you know IETF, right? Internet Engineering Task Force. I already said you can be the member of that group free of cost, right? It is the group which may help us in managing the internet, and anything has to be protocol or any important document. First, it has to be in form of RFC. So all those RFCs are available on the IETF portal, right? And there are a lot of groups running. So if you are interested, you can also be the part of that group, and you start receiving the communication related to that, right? So I request all of you to maybe do some exploration on this part also, right? But this is what the, let me take you back to the presentation part. So share, you got an idea, right? So whatever the things that you are measuring, or for example you are providing a continuous streaming of the image, a continuous video streaming, let's say for example, but it has to be shared, right? So where this kind of mechanism and protocols will help you. And finally, the layer number 4, right, which is of compose, and you understand the meaning of compose, right? When the things are on the web, that is layer 1. IoT के ऊपर वाला याद है ना आपको, लेयर 1 ये रहा आपका, देखिए लेयर 1, access, find, share, and now fourth one is the compose. Let me take you to that. Once the things are on the web, that is layer 1, where they can be found by humans and machines, layer 2, right? जैसे मैंने आपको सर्च इंजन बताया, and the resources can be shared securely with other, layer 3. It is time to look at the how to build a large scale meaningful applications for the WoT. In other words, we need to understand the integration of data and services from the heterogeneous things into an immense ecosystem of the web tools such as analytics software and mashup platforms. Web tools at the compose layer range from web toolkits, for example, JavaScript SDK offering higher level abstractions, to dashboard with programmable widgets, and finally to physical mashup tools such as Node-RED as shown below. Right, inspired by Web 2.0, participatory services and particular web mashups, physical mashups offer a unified view of the classical web and web of things, and empower people to build application using data and services from the web of things without requiring programming skill. What we are trying to say in this presentation is about the compose layer, right? I want to tell you that whatever the data you are collecting from different sources, by means of IoT things and whatever it is coming up, and then at a compose layer you need to make a decision basically. So maybe let's say you have received a temperature value on 6th February at 3:45 p.m. for a specific place, and that temperature value is 25. Let's say, assume, and you have a record of last 10 years. And according to your record, this is the first time you are seeing this value of the temperature, right? And that analytics come out. That means your entire at compose layer you will get some alert. This is the something which has not happened in the history, and it is happening first time. So you must get an alert. So what they will do, probably it start showing you the live streaming, and other sensors get activated, and you start getting some other values also, right? This is what we are trying to say at the compose layer, right? And I wish you to explore this Node-RED part also. You can go to that website. So this is, again, let me take you to that compose layer, right? And now look at this diagram. This is a complete explanation what we did till now. On the left hand side, what you have, can you read it? I hope you have you are reading, and I wish all of you to read from the left hand side. Listen for PIR, right? Check for PIR value, prepare a lead message, right? LED message, turn LED on or off, get a snapshot, copy image, and tweet, right? This is the entire mechanism, starting from lowest layer, that was the things connected to the layer number 1 was the access layer, layer number 2 was the find, then the layer number 3 was the share, and layer number 4 was the compose, right? So this is a classical diagram which is trying to represent everything, right? So I hope I have tried to explain you what do we mean by the web of things, and let's try to look at this is the last slide for today's session. I will not stretch much, so be with me. uh, this is the very important slide related to today's discussion, so just we want to finish on this part. This was the pre-internet era, so there has to be human to human communication, right? And fixed and mobile telephony and SMS. I don't know. You can speak to your parents probably when they used to send some messages to the friends and the parents. When we were during my BTech program, I used, I was from the city area, and my some of friends were staying in the hostel. So if they have to pass some message to their family, they used to write a postcard and they used to give me, and I used to go to that red dabba and put into that, and then after 1 week their family will receive that postcard and then they will reply, that was the pre-internet era actually, right? Even the mobile phone, landline phone was rare actually, right? So, and we used to have an STD PCO as a business. Then internet of content, like email, information, entertainment, right? Then we have a web 2.0 where we have a e-productivity, e-commerce and everything, Ishwar become e-Ishwar or something like that you can think of. Then we came to the social media like Skype, Facebook, YouTube, and I'm sure you must be missing WhatsApp, right? It has to be here, right? So that's a social media, and now that's the internet of people. This is the internet of services. This is the internet of content, and this was the pre-internet era. And now we are saying internet of things, right? So when I say internet of things, it is not only the things to be get connected to the internet. We wish a machine-to-machine communications to happen. For example, let's say we are staying in some area where my power cut is more frequent. I mean, for example, let's say you are from Uttar Pradesh or a place like Uttarakhand, like Roorkee. If I speak about Roorkee, if you visit a city like Roorkee, you will find out that every bank, every shop has a generator, right? And if you are from Gujarat, probably you feel, अजीब सा लगता है कि यार ये सारे शॉप, वो स्वीट वाला भी है ना, वहाँ पे भी बाहर जनरेटर का सेट लगा होता है. हमें लगता है कि ये स्वीट वाला क्या जनरेटर सेट, बट वहाँ पे प्रॉब्लम ये है कि पावर की going out and in and out, right? So let's say if that is the scenario, we wish that our refrigerator should communicate to our power supply or UPS, right? Maybe we wish that our television and watch should communicate internally. So if I have done a programming like in any situation, if it is at 10:30 at night, my television has to be off. So there has to be a communication between your watch that you've set. Probably, let's say if it is a smart TV, you can have an argument here. It already have a time. That's fine, right? But still, let's say you want some event to happen. For example, let's say, uh, for example, you can say there is a heavy darkness in the society and nobody is moving. You want something to be off. Let's say street light to be off, right? And then if person is moving, that street light has to be on, the camera has to be on. So when street light become street light is on, it has to switch on the camera also. So that machine to machine communication has to happen, right? So that's what we mean by the internet of things. So identification, tracking, monitoring, metering, right? So this is what the evolution is going to be, and people are talking about nowadays the internet of everything and web of things. I already explained.